Hi, this is the final project, Generate Monet painting using GIMP. When I was in grade school, I was deeply impressed by Claude Monet's masterpiece, especially Water Lily Pond, which I got introduced in one of my visual art class. I was a very bad painter myself, but I have a dream of producing masterpiece like him, but that never happens. That's why I took on this Kaggle challenge, which requires me to translate photos into Monet style paintings. Given the input photo, the competition requires me to generate more than 7,000 Monet style paintings. So, this is an image to image translation problem, which CycleGAN is very good at. So, I implement CycleGAN, which consists of two GANs, two generators, and two discriminators. The highlight of CycleGAN is the cycle consistency loss, which is the L1 distance between an input artifact and a reconstructed artifact after a whole cycle. To illustrate this, let's look at generate N. It takes an input photo of P, then produce Gmonet P, which is a fake Monet image. Then we feed this Gmonet P back into generator P, which will convert into a photo again. So this is essentially a reconstructed version of original photo P. So the whole cycle's goal is to minimize the reconstructed version of this photo and original photo. This cycle goes in the other directions too, and this is what the whole training cycle is about, minimizing the cycle consistency loss. So to design this experiment, I designed two cycle GANs. The first one serves as a baseline, using CNN, a package style CNN as discriminator, and inspired by MP2, I decide to try ResNet 18 as a discriminator for my CycleGAN 2. For both experiments, generators are keep the same. The generator is typical, a downsampling, residual, and upsampling layer generator. For CycleGAN 1, we use a standard package style CNN network. For CycleGAN 2, I use a pre-trained ResNet 18 with the last layer modified to have the output dimension of 1, which indicate real or fake. And all parameters are frozen except the last fully conducted layer during training. The training data provided by Kaggle 300 Monet paintings plus more than 7,000 photos. These photos and Monet paintings are not paired, so my data loader has to pair them together and feed them into the network. All the data are used for training. Since there's a generative task, there's no test data. So these are the results of my experiment. CycleGAN 1 produced really impressive results. However, CycleGAN 2 has decent results, but not as good as CycleGAN 1. These are the side-by-side comparison between the original input photo and the generated Monet. As you can see, CycleGAN 1 adds Monet style to the painting as well as capturing most of the feature of the original input photo. However, CycleGAN 2 produced good results, but the results are too similar to the original photo and lack the feature of a Monet style paintings. The two models have vastly different style in the generated samples. Let's look at the training losses. The training loss of CycleGAN 2 is much more stable and has a very, very steep loss curve and a much lower final training loss than CycleGAN 1. However, the FID score says otherwise. So, evaluating generative images, here, using visual evaluation can be highly biased. So that's why we use FID scores. The lower indicates better. CycleGAN 1 outperforms CycleGAN 2 in terms of FID score. Conclusion. This project completed the basic objective outlined in the project proposal by generating more than 7,000 Monet-style paintings. However, ResNet 18 discriminator does not outperform packaging-style discriminator due to possible overfitting. As you can see, the learning curve, it has a very low training loss, but the photo it produced are too similar to the Monet-style painting it produced are too similar to the original photos, which possibly indicates it's trying to minimize the cycle consistency loss by too much, resulting in the reconstructed photo being way too close to the original input photo, despite having a really good stable training process. And the fine-tuning pre-trained ResNet 18 may provide a possible alternative for implementing discriminators for cycle gain if we can somehow apply early stop techniques to prevent overfitting of the ResNet 18 approach in cycle gain 2. This project is an individual project, so I'm responsible for the entire workflow. Thanks for watching.